My name is Zlatko, and alongside with Dario, I'll briefly try to explain a bit of the networking in Kubernetes. But before we actually go to Kubernetes, let's briefly explain networking in general. It will be a very short one. So, as we know, internet is vast, and you need multiple tools to allow users to reach their applications. For that, both hardware and software solutions are needed. Besides just simply routing traffic from user to application, you also need to balance traffic. This is where HAProxy comes in. With its speed, reliability, and many other qualities, HAProxy managed to be one of the critical parts of infrastructures for more than 20 years now. So it's a bit short, but let's focus now on Kubernetes and and how networking works in Kubernetes. So, first, we need to explain what is Kubernetes. There are many definitions about Kubernetes, but Kubernetes can be seen sort of as a tool for automating deployment, scaling, and management of containerized applications. So, all the principles that you actually have in networking outside of Kubernetes basically remains the same inside of it. So, let's see how exactly this works.
Thanks, Zlatko. So, let's start from the beginning in Kubernetes. So in the early days, we just had few resources out there. And one of these was the pods. So the pods are the basic concept for our workload. So if we got our application, we got a pod. Let's try to skip all the replica set, replication controller, deployment daemon sets, and so on and so forth. And then, obviously, we got our pods that are our applications, and we need to get these applications reached by other services. So we need an additional object, an additional API object, and that's the service. And then, obviously, we need a sort of collection of IP addresses, because on Kubernetes, each pod is going to get its own IP. So we got the pods, the workloads, we got the service that are going to provide a sort of fully qualified domain name to reach out to our applications, so it's used for the service discovery, and then we got the endpoints, a collection of all the IPs. And after that, let's try also to dig up what are the services. So we got multiple types of services. We got the cluster IP, the node port, although we got also the load balancer, but it's a sort of node, the load balancer is node port on steroids, and then we got the external name. In the cluster IP is the default way to get applications exposed to other applications. I need application foo to reach out to the application bar. I'm going to create a service. This service, the cluster type, the cluster IP, is going to get a cluster IP, a virtual IP, that is just used internally. So I cannot use the cluster IP to get external access to my workloads. So how can we solve that? We need to use the node port, at least at the beginning of the Kubernetes era. So with the node port, we can say, I want to get my application exposed externally, so I can use any node IP address of the cluster on a specific port range, mostly in the high range. Eventually, you can use also the privileged ports, but it requires more hacking of the pod template specification. And with the node port, we can get also a load balancer. But the load balancer is going to provide, well, I'd say it requires a deeper integration with the cloud provider. So finally, we got also the external name, although it's not used to perform external access. Keep in mind that in Kubernetes we got a lot of IPs, we got service discovery, and the external name is just used to map an external service that is outside of the cluster to be considered part of the cluster. So you got a fully qualified domain name in the Kubernetes context that is going to be addressed using core DNS or eventually the DNS you decide to use to an external service. So no proxy of any kind. So let's try to recap everything in this nutshell of Kubernetes 1-to-1 course. So in the early days, we have to create our deployment, so our workload. We need to create a service that must be of node port or load balancer. And there are some problems. There were some problems, because now we are going to see that have been solved. But how can I terminate TLS my application? So how can I get a certificate to get an encrypted connection? how can I get also the logs? Because it's really easy to get an application running on Kubernetes, but that's just the day 0 or day 1. In day 2, I want to get all the logs, to read all the logs, to get the information, to detect anomalies, and so on and so forth. And keep in mind that also the node port got some mutations, because I have to use a specific port numbers, and maybe my application must be exposed externally using the port 80 or 443 because it's web application. And then also the load balancer solution, I need to rely on the cloud provider. So it means that I'm running on cloud, but if I'm running on-prem on my data center, I am the cloud provider, and I have an additional problem to manage. And last but not least, all the HTTP rules. So how can I manage read writes, read write rules, and so on and so forth? And up to you, Zlatko. What's the solution?
So there's clearly need to describe how traffic flows, and Kubernetes introduced concept of ingresses. So what does ingress actually mean? In general, term ingress is used to describe action of entering. In this case, action of entering traffic into Kubernetes cluster. In Kubernetes terms, it's an API object that manages external access to the service in a cluster. So it has additional use cases like SSL termination, name-based virtual hosting, and many other. So let's talk briefly about Ingress and various different implementations. As we saw, we have multiple of them. So first version was introduced in 1.1 version, and as it is seen from API version, initial life of Ingress began in extensions group. So why extensions group? Extensions group was there to add potential new options to the Kubernetes that necessarily didn't fit anywhere else. Contrary to the name, even though it was the V1 Beta 1, it was actually used, let's say, in production for more than 5 years because this was pretty useful and we will say quite stable. As time passed, a lot of objects got removed from extensions group. So at one point only Ingress remained. So networking group from Kubernetes decided to move that to a networking working group. So and with that change, users, of course, were required to do some minor changes. But basically, the only change that needed to change is the API version. Everything else remained pretty much the same. They added some options, but basically, the whole concept remained completely the same. It still remained beta, but soon after, with some minor adjustments, they moved to V1.
Yeah, exactly. Keep in mind that, just a side joke, in Kubernetes, V1 Beta 1 is production grade. Just joking. But right now, starting from 1.19, the Ingress API is totally stable because it's battle-proof. A lot of companies started using that in production. And keep in mind that I just want to focus on a particular of the Ingress API that we can see here, because from the beginning, the Kubernetes cluster was just used by a single entity, by the cluster administrator or the developers. And during the years, we noticed that Kubernetes started being a sort of platform. So it means that it can be used by multiple entities, multiple teams. So with that said, we introduced in the API definition the concept of class. So it means that I can have multiple Ingress controllers that are serving different teams. So I can define a class. So if I got 2 Ingress controllers, one for external access and the other for internal access, I can use the same API, but these APIs are going to be consumed, well, the objects of those APIs are going to be consumed just by the Ingress controller that is using that class. So let's try to recap from the beginning with the use of Ingress. So we need to deploy our Ingress controller, then we need to create our deployment, we need to create a service, and there is no problem here because we can use the cluster IP, because the communication is going to be from the Ingress controller to the application. So we don't need node port load balancer because it's intra-cluster communication. And finally, we need to create our object, the Ingress. And that's great because in the end, we are totally declaring how we have to manage the infrastructure. But obviously, there are some pros and cons. Let's try to recap briefly. So it's great because I said we are using Kubernetes to do all the stuff. We do application, we do infrastructure, all in a declarative way. We can deploy anywhere because the Ingress controller can be deployed on-prem, could be deployed on the cloud, on the developer's machine, and really important, there is a controller. So all the changes are declarative, and upon a change, the controller is generating the configuration on our own. So you don't need to do SSH to the machine, edit the HAProxy configuration file, and so on and so forth. But obviously, there are some cons. And the cons here is the fact that there are some limitations. And I would say that how can we manage the advanced routing? How can we address some custom features like the HAProxy ones, and what about the security, the certificates, the mutual TLS communication, the TLFS offloading, and how can we manage TCP? I know it sounds really weird because we are talking about Ingress, so layer 7, but TCP is layer 4. So how can we solve everything with annotations? Our annotations are a real way to manage that, but let's try to put questions one-to-one and try to answer them.
So we saw that Ingress object has some benefits, but of course has its own limits. So it was relatively simple, but you needed to basically do a lot of customizations, as Dario said, with annotations. So as Kubernetes evolves, some new ideas came, and networking specialists group decided to think about that, and some new ideas came. With that, they introduced Gateway API. So the concept of Gateway API is slightly different, and I'll go into a bit details about that. First release, Alpha 1 release was launched in 2019. Many things got redesigned, and the key advantage, I would say, of the Gateway API is that can be much more expensive and much more extensible, because by design they allow adding of custom resources inside of actual Gateway API to extend all the features that needed. Also, Gateway API is not designed to be built into actual Kubernetes API. Same, for example, Ingress controller is inside of API and will remain there. But there are many reasons why they decided to do that, but I'll just mention the most popular ones. So they are not tied to the actual Kubernetes version. So when they release a new version or they update something, you're not tied to the Kubernetes. You can even install it prior to the versions they even existed in 2019, even though we are speaking about something relatively new. Also, there's a great advantage of not being tied to the Kubernetes API. Actually, it's a different release cycle. So they have more time to develop things, to think about things, and slowly adding them in. So what's the idea, actually? So not every part of actual Kubernetes and the whole infrastructure is maintained by the same teams. Some of them are only concerned about traffic, some about infrastructure, and some just want to, well, add their applications in Kubernetes clusters. In fact, we can have multiple teams that are describing and handling the flow of the whole traffic. So for example, we can have infrastructure team, platform team, and the development team. So what would be pros and cons of the Gateway API, actually?
Yeah, let's try to summarize everything. I would say that the Ingress API has been abused because in the end we had many requests also on our side to implement TCP in Ingress. So it's not the proper way to do that. Instead, the Gateway API is addressing that natively, so we can focus also on TCP. And keep in mind that UDP is on the roadmap, and it's really nice because in the end, in the Kubernetes ecosystem, you can join the SIG, you can say, I would like to get this feature, and you can talk with the developers in order to get a feature request, an enhancement proposal. So it's great because behind Kubernetes there is a huge community, and you can be part of that. Keep in mind that Gateway API, obviously, it's a bit complex. I have to say that honestly. And that's great, also the fact that it's not implemented in the Kubernetes API. It means that you don't need to stick to a Kubernetes version. So Kubernetes is going to be a sort of platform where you can build all your components of the infrastructure. And these are not tied to the Kubernetes version. So you can move all the things in your way. You can build your own platform. And also the fact that we got multiple personas in the diagram that we saw before, it's really great because in the end we are empowering teams to manage their own infrastructure, so creating an abstraction of the platform. But obviously we have to talk also about the fact that is Ingress API dead? And honestly, I wouldn't say that, because if you need to get simple traffic, simple HTTP, most of the use cases, Ingress API is the correct way to handle that. And also keep in mind that it has been landed in Kubernetes, so it's GA, so it means that Ingress API is there to stay for a long, long time. But obviously, we have also to talk about how can get an Ingress controller deployed in a Kubernetes cluster. And keep in mind that it's really simple, because we got the Helm charts. So Helm is a way to package applications to get installed in your Kubernetes cluster. You just need to specify the release name, the namespace. We got all the support for the options. And keep in mind that in the end, we are ending up with a controller that is deployed by a deployment or a daemon set according to your needs, that are watching all the events from the API server and according to rules that are defined in the Ingress API instances are directing the traffic to the services. But there is also a nice way, because this is internal, but let's talk also about the external.
Yeah, beside our regular setup, where Ingress controller should actually be, we kind of have a different way of running Ingress controller, and we call it external mode. So it's basically run outside of Kubernetes, but it still behaves like it's run inside of it. Of course, there are some requirements, especially network constraints and some different problems, but it is manageable and can be done. Unfortunately, we don't have now time to explain it, how it can be done, but on our HAProxy pages, there is a documentation about it, and I think there's even a GitHub repository that we created to specifically show an example how this can be used. Yeah. Not only that we can run it externally, but when we are talking about networking and everything, observability is a pretty big thing, and we need to take care of it. So we have, of course, HAProxy logs, and both HAProxy and Ingress controller offer Prometheus data that you can use to further customize and fine-tune everything you need. This is mainly concerned with a different topic, and it's called security. We cannot forget about security when we are talking about network traffic. And HAProxy Ingress controller offers some security advantages or features that you can use.
Yeah, absolutely. Keep in mind that also if you're using the Ingress API that got some limitations, with the Ingress controller you can specify some rate limiting options. You can define also allow and deny list to perform a sort of ACL, and you can also increase the verbosity of the logging, so you can use the access log or also the Ingress controller logs to detect anomalies. And last but not least, we are also supporting the config snippet and the CRDs. So the config snippet is a way to inject your own code inside the HAProxy configuration, so you don't need to SSH, although it's not SSH, but exec in the container and add weird configuration. You can do that using natively the Kubernetes API objects. And with CRDs, we implemented custom resource definitions, so it's a way to map primitives of the HAProxy context domain context to the Kubernetes one. So you can create resources from there in order to get published automatically on the HAProxy configuration.
Yeah, but this is not where security offerings ends. We also have some enterprise-related features, and this is where web application firewall comes in. It's a solution where with more security rule sets, applications can be protected from sophisticated threats that are left unhandled, for example, by network firewalls. Additional tool we have, it's called global profiling engine that kind of unites all Ingress controllers you have to behave as one unit. So they sync all the statistical data information that you can use, and you can use that to further enhance and secure your Kubernetes. Yeah. So I would say with this, we are concluding our presentations, and I'll leave that to Dylan.